Yeah.
Oh, this is what I'm expecting. And then COVID lifted it. Like, oh, okay, this is
This is more like real life.
Yeah.
Strange. Okay, we're up and going whenever you're ready, Patrick.
Perfect. Thank you all for being here. This is Weather Watch right before spring break. I'm excited to show you what happened. There have been two really big cyclones, this one right here. You'll wait for the next one right afterwards. And there's very interesting things going on with both of these I will take a look at in the past weather and then set up the current for the forecast here. So that was one cyclone. It's currently sitting off the East Coast. Here's the next system that moved over central portion of the United States. Essentially did the same impacts over our region, but had two very different impacts for the south. This first one produced a lot of tornadoes in the south. You'll see a lot of convection here, moves offshore. The next one that comes in essentially does nothing to the south other than make it cold. And we'll see that reflected in the clouds right here. But I'll go through these because they are very interesting. So you'll see here's the second system. No convection or any precip whatsoever in the south here. So stepping through this, first go back to the first cyclone here. If we could stop it at March 14th, 23 UTC, please. So I picked out a couple interesting times here. So this is perfect. So here we have the cyclone sitting somewhere over Kansas City, Missouri here. You can see a lot of bands of clouds and convection and rain and snow extending all the way out from the center of the cyclone. You can see the cyclonic rotation in those bands, essentially affecting everywhere from Hudson Bay all the way down to Texas. While this was happening, I remember pointing this out, there were a lot of fires and dust and smoke and everything going on from New Mexico, Texas, getting wrapped up in the system here. All of this emptiness in, all the way up to like Omaha, Falls City, Nebraska, this is all smoke and dust that was wrapped up in this really strong cyclone. If we keep going here, actually I want to point out, sorry, if we could go back. March 14th, Pi Day, Madison tied the daily record. We got up 78 degrees Fahrenheit. So we didn't break it, but we tied the record right before the storms and everything moved in our region. So that was interesting. If we go to March 15th, so a day later at 10 UTC, please. So you'll see, nice cyclonic swirl. Here we have a really well-developed cyclone, nice cloud head wrapping all the way. You can see the cyclonic rotation. At this time, all of this emptiness within the clouds, this was all smoke and dust from New Mexico, Texas, and Oklahoma. A lot of fires in Oklahoma. They got wrapped in the storm, so places got hit by tornadoes and then had smoke and dust falling on them. At this time, I was outside walking, maybe not this early, but later. We were under unhealthy air quality from the dust and the smoke. So that's how impactful just bringing particulates from the south all the way up into Canada is where this stuff reached. You can see this is a really nice dry slot, the so-called dry slot, where you have a lot of descending air, it dries rapidly. You have a nice band between where it's really moist, where there's clouds, and then it's really dry. And you can see that, it sort of just punches a hole into all of the rain and snow and everything that was going on. So this is a nice picture of a dry slot. And we were the beneficiaries, or unlucky people when we got all the dust and the smoke and everything. So that's interesting in and of itself. And this is storm number one. At the same time,
did you hear about the Oklahoma mesonet site that had a fire go by?
Yeah, that's right.
The last reported temperature was 176 Fahrenheit.
Whoa.
Yeah, I don't remember which one it was. Then the winds went to zero, which they figured the thing that melted.
Yeah.
Right.
Yeah. And
Somebody out there is thinking the rapture is at hand.
Right.
And I remember at these sort of times, same thing with earlier where there was dust. Some of the mesonet sites were reporting precip because the dust was so heavy it was falling and tricking the sensors into thinking it was raining.
Wow. Crazy.
And it's 70 Fahrenheit over -10, so there's no way that that's actual precip. But yeah, that's just crazy. And I don't know if any of it made it to the ground necessarily. I had dust on my car on Saturday, but nothing, places were getting buried in dust closer toward the south where it originated from. So this is storm number one also, and there were tornadoes ongoing in these convective elements, the deep reds, higher clouds, taller thunderstorms. If we could go to 20 UTC on the same day, so we'll see, here's our cyclone, the first one, moved off into Ontario. You can see the cloud band associated with it. This is nowhere near the main feature though, ongoing at the time. A secondary cyclone, you can see formed in its wake. And here we had our high severe outbreak in the southeast. A lot of tornadoes, a lot of strong tornadoes, both on March 14th and March 15th. Total of 192 from this single system. And then, that's only one impact. There was cold air wrapping up behind it, there was dust, there was smoke. So just crazy system. And you'll see as we march forward.
Excuse me, Patrick.
Yeah.
I think we have an image of from SPC of the storm reports for that, if you want to just.
Oh, yeah.
Inject that for just a moment.
Yeah, absolutely. We can go there. Yeah, so this is March 14th.
Oh, it doesn't.
So remember, if you remember back to Weather Watch, I said correctly, which I'll point out. The northern portion was main wind. All the blue dots are wind reports. Southern portion, like south of, St. Louis, here's all main tornadoes. So it was a nice divide. Even some tornadoes I'm seeing near Chicago, it looks like. This was one day, and if we go one day forward,
What's the best way?
is there one? Here.
Yeah, right there.
Here's the second day of the system. So a lot of more tornadoes than the wind, but a lot of these were long-tracked, very strong tornadoes, both on March 14th and then this is March 15th, you can see. So very impactful system
Right.
as it's tracked, yeah.
Another element, I don't know, Pete, if you could click on the product archive, where is that? And then put in the 14th, I guess, first, maybe the 15th for the end. Kind of neat just to see how well things verify.
Oh, yeah.
And then maybe the
Oh,
day,
yeah,
the
yeah.
day one, 1630, I guess, might be the,
Which one, that verification?
yeah, verification, I guess.
Yeah, look at that. So, great forecast. Like I said, also, any thunderstorm can produce any of these hazards. So anywhere that's highlighted essentially could have produced any of these, but the main severe threat, the moderate, the red right here, kind of the bullseye where you saw all the impacts. Some of the thunderstorms that went through were impacted by the dust. So, places that maybe they were expecting really strong storms didn't get as strong because you had a dust storm sitting on top of you. But any one of these impacts, in my opinion, one tornado verifies the need for a really high severe risk. You don't need hundreds of tornadoes for it to be justified, I think. So seeing this is really good.
Yeah, that's amazing.
And it holds for the next day too, where the bullseye was over the southeast, essentially Tennessee, Mississippi, Alabama, and that's exactly where we saw all the tornadoes.
Yeah, we can even go ahead one click, I guess on the left, there's a,
Right.
yeah.
Oh, yeah,
link to
yeah.
it. I did have a map on it, yeah.
I think,
That's misleading, you think it would be.
yeah. Or maybe it stops on the 14th.
Okay, well, that's,
Yeah, that was a stunning success.
Yeah, absolutely. And understaffed too, so
Yep.
these people are working 20-hour days.
You heard Green Bay is only launching one sun.
Yeah, now we're under observed, yeah.
Yeah.
oops, you missed the delete
Oh, yeah.
15.
I'm still missing something.
No, that's good.
I think it looks good. Yeah, there we go. And then 1630 again. Yeah, exactly where you saw the highlighted severe risk, that's exactly where the storms happen, especially the really strong, long track tornadoes. You can kind of make out the red dots go in a line, that's probably one single tornado tracking from all the way from Louisiana into Alabama.
You don't issue high outlooks very frequently.
Right.
Yeah.
It's
Yeah.
usually, a lot of times they're the bane of this.
Yeah.
Like if something happens, it's gonna be insane, but there's a cap that has to break.
Right.
Usually if I'm chasing and there's a high risk, I get
And I
worried.
don't suspect as many times where the axis of the high forecast region is the long track tornado.
Yeah.
And then
Exactly,
there's
yeah.
a collection that turn off to the right.
Right,
It's pretty
yeah.
unbelievable.
True. And so who cares if
No
you're sitting
shot,
right
you
here
be
and
quiet.
didn't get a tornado? there was one
Yeah.
just to your south, like, I don't know. There's a lot of debate whether this should have been a high risk, and it doesn't really matter.
So they did a great job with that.
Yeah,
yes.
they nailed it. Aside from this one report, but that's just a wind report.
Some guy in his backyard, ooh, it's windy.
Yeah, 50-mile-an-hour winds in Missouri, yeah, exactly. Okay, so if you go back to the loop, so we stopped March 15th. Here's those supercell like storms moving over the southeast. We could step to March 16th at 1750 UTC. We'll see these move towards the east. There you go, yeah. 1750, please, in the afternoon. So here, that marches past. We get sort of the backside rain. It was mostly just cloudy over us. There were a couple reported severe reports over the mid-Atlantic and northeast. Nothing as extreme, but you can see from the cyclone, it's a lot more dilapidated, not a nice cloud structure, but it extends all the way into Canada, and if you make out the cold front, it goes all the way into Mexico. These really thin, low-level clouds, so impacting in continents scale from just one system, and creating a lot of destruction, but then just impacts everywhere essentially.
It's bigger than tropical cyclone scale, isn't it?
Way bigger, yeah.
Yeah, that's
I think
true,
so,
but
yeah.
another interesting aspect that's, we haven't mentioned yet, I'm sure this is gonna be the bulk of your discussion, is that little cloud
That
mass
is
off the, in the central Atlantic. And,
Maybe a little
and we'll watch as we step forward, it actually evolved into something that the Hurricane Center actually put a 10% outlook on, they actually
10%,
began.
yeah.
So,
That's true, that is interesting.
Yeah.
Interesting.
early season,
Is
that didn't happen.
a cutoff, a wave-breaking event right after an SSW.
Yeah.
Interesting.
I don't think there's no association there, I wouldn't worry about
Wave-breaking
that.
and
Another thing, the dust was a feature of this cyclone. Dust storm would have just killed this off. So,
Okay.
I don't know what's more interesting, this little cloud band right here, who knows what that is,
Boy, he's
or
getting good.
yeah.
this.
So, just a question.
Yeah,
You can forget the subtropical, whatever that
Sure,
was.
sure. whatever,
But for
yeah.
the dust, could the dust have also helped with hail production in terms of providing that air, those particulates, providing sort of cloud condensation nuclei?
Absolutely.
Two ways that.
Well, what about this? What about the flood of CCM that makes it
Sure.
harder to produce big droplets?
Yeah.
So it might be a suppressant more than anything.
Yeah.
But it's an interesting question. It depends on the size of the dust, how hydrophilic it is and all that.
Yeah.
But there's a possibility that it actually floods the system.
Good point.
So-
Too many things competing for moisture, and you just erode all the moisture. Also, from being outside, I smelled smoke from
Yes.
Yeah.
that. So
Yeah, that
smoke
was
is
pretty
notoriously bad for CCN because it's just too big.
Hmm.
So I think the combination of that and you had sinking air probably,
I said especially
That's-
going with the dry slot.
yeah,
Oh,
it was
yeah.
just a bad
It's
combination.
gonna starve everything of moisture.
Right,
Yeah.
yeah, for sure. So we saw barely any precip.
It is interesting, though, that it was coincident with the dry slot. Maybe it always is, because otherwise, without the dust, the dry slot is the most pristine air in terms of CCM because it's
That's
coming
right.
out of the stratosphere.
That's right.
But then you've got dust from the lower troposphere involved. I wonder if that changed anything about at the poleward edge of the dry slot, there's
Yes.
the destabilization that goes on, it's dramatic, and I wonder if the CCN had anything to do with that.
Right. Could we go back to March 15th, 10, around 10 UTC? We'll see that. The exact picture. Yeah, right here. So there is a preferred region right on this poleward
Yeah.
edge, but with all of the subsiding air, maybe there's some sort of convective element in this, but largely it kind of just eroded any chance of any storms,
Yeah.
it seems.
Really interesting.
So, okay, if we could go then to March 17th at 18Z. We'll keep stepping through here. So March 17th, our storm's over the Atlantic now. We have a band of precip. I believe there was some snow in this, but it didn't really affect us. We warmed up right after we were in the cold air from the cyclone that moved off to the east, and the west was setting us up for the next storm here. You can see it's generally just a messiness, but you can make out the trough in these really high clouds. the cold convective elements within the really cold air. So here's our trough moving towards us, setting the stage for our system that happened Wednesday over our region here. And then another thing I want to point out, over Hudson Bay, there's like this perennial cyclone, something that swirl that you can see throughout this whole loop. So if you don't want to listen to what I'm talking about, look up here, because this just cycles over itself. It's kind of really neat to see. So setting the stage for our system.
Or look at where your elbow was, the
Yeah,
thing in
that is
Atlantic,
interesting.
that gives me
That
better.
little tangle
Let's see,
thing up.
this whole feature versus this, I don't know. I don't know. If I can cover it up with my arm.
It's cute, Michael.
Yeah.
I'm pretty sure the thing over Hudson Bay goes to 30 kilometers.
Really?
Vertically
Wow.
stacked.
Yeah.
Is the bay frozen? I mean, is it frozen over? It must still be
It's
frozen.
still frozen,
over.
yeah.
So that's just spinning because of what's going on aloft. It's
Right,
not
exactly.
convective
Yeah.
coupled.
Okay, if we could go to March 18th now, 18 UTC, we'll see our system move over to the east. Here's the next development of our cyclone. We'll see it really come together at this time and then afterwards. But we're starting to see the moisture transport from the Pacific, really high moisture, moving over the desert into our system. We have that trough moved on shore over the west, and now we have the makings of our storm system producing snow now, Montana, Wyoming, into Colorado. Over us, we had a nice day though. It was, I think, in the 50s and 60s, so we had a nice warm up. And then if we step forward to March 19th, at 16Z, we'll see the system wrap up nicely. We had another dust event. All of this on the backside is dust, and we'll see that from another loop here. But this becomes a really substantial cyclone, as you can see. It didn't have the southward extension as the first cyclone, the Pi Day storm, but this was producing heavy snow and rain, portions of Kansas all the way up to our own state here. So we'll take a look at that in more depth. And then there was the dust that was all on the backside again. So 2 dust storms within a couple days of each other is kind of weird to think about. Here's that tropical system.
Well, that's a different one.
Oh, it's a different one. Oh, okay. See, I didn't even notice it because.
It's not even tropical. Yeah, it's a remnant of an extra-tropical thing. Doesn't look
Oh,
as
okay.
impressive, does it?
No, not at all.
With the dust storm over Nebraska right now, I have a friend that lives in the Lincoln area, and with the dust, and she had a blizzard warning the day before, and
Yep.
then the next day, it looked like with all the dust, it got super, super wet, and it looked like it was raining mud.
Oh, wow.
Right,
It happens
yeah.
sometimes.
Yeah.
She sent a picture of her car just covered in mud from like the
I'd like to
vertical
see that,
area.
yeah.
It was crazy.
That's cool. It happens in south of France, because they get Scirocco's off of the northern part of the Sahara that can do that, apparently. Wow.
These are the days that it's nice to live on the plains because the day before it was 84 in Lincoln. The following day it was snowing, blizzard, 70-mile-an-hour winds, 6 inches of snow. So those are always fun when you know something's about to happen, but it's 85 degrees and sunny outside.
It's fun.
It's very fun. Could we look at the loop you made, Pete? So I want to investigate this specific time here because there were some really interesting things going on, and we can just keep looping it.
That's gorgeous.
We'll let it loop through a couple times, and then I'll pick out some features of this. So Pete made this loop. Thank you, Pete. This is really cool. This is essentially the same time I was just showing and going 3 hours or 5 hours in the future. So you'll notice a couple things. First, I want to look at the western side of this image here. Here's our cyclone. You can see a nice cyclonic rotation. There's even the stadium effect to the clouds right at the end here, where you have higher clouds and it descends into lower clouds, so you can see like a bowl shape, like a football stadium or a soccer stadium. If we could pause it at the end, I'll point that out here. This happens a lot in tropical cyclones, which we've heard about today. So you can see here's the higher clouds. You can see them wrapping around, and then as it gets lower, there's some shadowing going on. So here's your cyclone over north central Missouri, right there. At the same time, if we just go back to the loop, please. There was a band of heavy thunder snow all the way from Nebraska into Wisconsin. Heavy, heavy snow along this band. You can see all the convective elements moving up, the really puffy clouds, moving into that snow band, and then they get swept and wrapped around the storm, especially over Iowa right here. We were getting some rain and some thunder and some hail, everything like that. really fast cloud movement. So I said 70-mile-an-hour winds in Lincoln, which is right about here. If you watch these lower clouds, look how fast they're moving, especially right there. Strong northerly flow on the backside of this. We were having northerly flow at this time when all the clouds were moving southerly. So very strong shear, most likely helping all the thunderstorms, but a really impressive event. We had a couple rounds of storms and rain and hail and everything. At the same time, so now let's focus on the eastern side. All of this brown that makes its way, we'll see, can we stop it at the beginning? That's perfect. So here's dust from New Mexico. Here's dust again, extending all the way, all this brown, gray shading. Some of this fell and even was observed in La Crosse right here. So you had rain falling, it would drag the dust down and it produced like mud rain essentially. Didn't really see that over us, although there were some times if we step forward when this dust makes its way just into south central Wisconsin, there were some times where the sky looked a little yellowy. And so that can be due to hail, but I think it was also due to the dust moving over us as well. Largely though, all the precip was to our north and west, fortunately or unfortunately for us. And if we let it play here, if you were wondering what a warm front looks like at the surface, here you go. So look at central Illinois, and I'll let this loop here. Do you see the band of clouds right there? There's a really low level band of clouds, and I'll let this loop through a couple times. Right there, you can see it's coherent. It stretches all the way from Indiana into Iowa. That's a warm front. So usually you don't see this because warm fronts have a ton of associated clouds. It's kind of messy, but this is a really thin warm front that existed over Illinois and essentially moved just westward. You can see it's not really moving north or south. I'll verify that this is a warm front, even though that I'm just telling you it. But that's what a warm front looks like. So kind of interesting. And on the south side of it, you had storms develop and then move up into the Chicago area. There were some tornadoes reported with these storms around the Chicago area and then into central Illinois as well. So this band right here, that's what a warm front looks like. So kind of interesting. I've never seen that before.
Me either.
So could we go to the satellite or surface plot that I sent you?
I don't think I grabbed that.
Oh, that's good. We can do it on the fly.
Oh wait, yeah, that was yesterday. Shoot.
That's good. If we go to Plymouth weather, which is up here, I remember what it was. And then let's go back if we can. Or just go to surface, make your own, archive, and then variable, we'll do station plot F for Fahrenheit. And we'll do March 20th, I want to say. I believe that's the time, or 19th. 19th. And then I think it was 18 or 20 UTC maybe. We can try that.
Should we zoom in?
Yeah, and then scaling, let's go to 0.7. It just makes the actual value smaller. And then map size, we'll do the largest one. And I think this should be good. We can zoom in here. Let's see. Here, let's go back one. I'll zoom into the Midwest. That'll be helpful. If we go to region, Midwest. Yeah, perfect. Here we go. So look at central Illinois. 70 degrees southerly flow, 73, around 70 degrees thunderstorming. Then you're in the 40s, just to the north. Yeah. So there was exactly where that warm front was sitting, and not moving at all. So, you know, central Illinois had a great day. You're outside, you're biking, nice day. Northern Illinois, 40 degrees and raining, terrible day. Same state, just a couple miles away, which is pretty cool. And I was just sitting right there.
Madison, a thunderstorm at 36.
Yeah, thunderstorm 36. We missed out on the snow band. You can see it back here with all the little stars of snow reporting. So there's the warm front, and then I think I have, that's good. One more time on the IR loop, just to complete things. Yeah, if we could go to March 20th at 16 UTC, so essentially a day later. We'll see our cyclone nicely wrap up. It becomes incoherent, essentially. We get our snow band on the backside, and then right about here, you can make out, in between these two systems, There's the snowband number 1. Very high snowfall accumulations, up to a foot in Nebraska. I think double digits in Iowa and Wisconsin. And then there's one more right there over northern Illinois. So same place, you had 70 degrees, tornado. One day, a couple hours later, you have snow that's visible from space. So interesting. And then if we let this play just a little, watch these snowband. I don't know if you can really make it out, but they melt throughout the day because we had a quick warm up. So
I think Pete has some imagery from that, right?
might be able to if we could go back one day. Oh yeah, here we go. So the greens are your snow. Yeah, here. You can see especially the southern band over Illinois just shrinks like that. So these were the lower accumulations. Higher accumulations were Nebraska into Iowa, Wisconsin, even into Kansas. Erodes throughout the day, so not lasting a long time. But still double-digit accumulations through a couple states, which is pretty cool.
That's my favorite imagery.
Yeah, that's nice.
And some lake effect snow, looks like on the backside here, or clouds. So that gets us to today. Could we go to the current visible? I'll set this up here. So we had a very active week, very interesting week in terms of weather. We'll do the color viz currently. So here's the system that brought us the snow briefly, the tornadoes over Illinois. You can see a very long cold front is coming all the way down into Cuba. So Canada to Cuba is this, and on the backside you can see cold air advection over the warmer waters producing these cloud streets here. In the interim, we sort of have some valley fog over the northeast. You can see the Tug Hill Plateau right there, nicely highlighted. Very heavy snow accumulations, like 300 inches from the winter, so that's going to take a while to melt, so we'll see that for a couple weeks, I'm sure. We're in this higher cloud sort of messiness over the central portion of the United States, and then the next system, you can sort of see it beginning to make its way into the northern central United States. Here's our cool down briefly, coming straight from Canada, where you can see snow cover still all the way in Canada. And aside from that, this seems to be the main thing going on over anywhere, in the central portion of the United States, aside from just clouds over Maine and some messy convection cloud systems over the west here. So if we could go to 500, I'll do 500, 850 surface, and then I'll be done talking. We'll start at 500, please. So here's a look at the trough ridge pattern currently. Here's our one system moving in from Canada. We'll see it better at 850, but you can see it's a nice trough. Cold air right on the base of the trough. Very sharp curvature feature, so that's making its way towards us. Right now, over much of just the central United States, we have a sort of uniform trough. There's a chance for some precipitation. I believe it might be in part due to this trough, but most of it is due to the passing of this system, which we'll see. Zonal flow, a slight ridge over the west, so that usually means we'll get warm after this system moves through. And then here's the remnants of our system. Very deep trough, sharp curvature, but moving over the Atlantic, so no longer affecting us in the United States here. And there's not really too much of a temperature gradient anywhere in the United States, the CONUS here. The main 500 temperature gradients are way off the Atlantic, and then with this system moving through. So not a lot of baroclinicity. In fact, even going from the Pacific into the west, it sort of spreads out. So we're losing the baroclinicity. So you might look at this and think, oh, there's probably not a lot going on besides this trough right here over the United States. And then I want to point out, because it's unfortunate, we're missing some sounding locations. This will continue, so be warned of that. Omaha is no longer launching. Rapid City and Albany, you can see nice holes, not nice, but holes of data. Even Green Bay, no soundings, unfortunately. So this should continue and might look less populated as we go forward. Just have to point that out. So if we could go to 850, please. A little closer to the surface, we'll see our cool down. So look at this baroclinic zone. the red dash contours. It's like a nose of cold air coming straight from Canada. The nice bulb of cold air is coming straight for us. And you can see really strong cold air advection. And it's differential, so this might be leading to some precipitation as it's phrenologenically active right along the leading edge here. But you can see this is mainly our cool down, is this nice little vortex, nice little trough moving from Canada and Hudson Bay straight towards us. Otherwise, there's a slight ridge over the south and the mid-Atlantic, so warm up, and we're sort of in the in-between where we're gonna get warm, and then as this thing moves through, it's gonna quickly cool us down. So if you can get outside now or after weather watch, do it, because it's gonna be cold after that. But I wanna point this out, because this is the main feature we wanna talk about, and then if we could go to the surface.
No tariff on that
this.
cold air importation either, is there?
Yeah.
What's that?
There's no tariff on the cold air that's imported.
No, yeah, how much did that cost the United States moving through? Yeah, so 52, that's pretty good. But you can see the leading edge of the cold air, maybe more of a wind shift at first, is right through Minneapolis. You can see colder temperatures on its edge.
5 degrees.
Yeah, 5 degrees, there's some negative temperatures up here, so really strong temperature gradient at the surface. Right now, though, we're sitting pretty nice. Hopefully we can get some sun, a little warmer, and it will be a nice afternoon before we cool down here. Other than that, there's snow and precip over Maine, but largely, looking at this picture here, the only other thing I can see is snow in Wyoming. So this is the main player for us, is that cyclone, not too intense of a pressure disturbance, but definitely intense in terms of the cold air and cold air advection we'll get going forward here. I talked for a long time. Is there anything anybody wants to see? Okay, I'll pass the baton.
I'm gonna show something. Yeah, at the risk of some marital turbulence yesterday afternoon, I thought I had to take advantage of this extraordinary situation. We had that little dusting of snow on Wednesday night to Thursday, and it melted, of course, in the part of my backyard where there is sun all day long. And this is the terminator line. And I've seen this every single year in the spring, but this was one day with one snowfall and one day of melting. Happens to also be the day where the sun is directly over the equator. So I thought, I'm gonna measure the height of the fence. How come I'm not going forward? Oh, there we go, okay. I'm gonna measure the height of the fence, 86 inches, and the distance from the base of the fence to the terminator line is about 81. Now, these are not precise measurements, but because I had to do it quickly, as I said, turbulence was afoot. So, tangent of that angle, 81 over 86. Oh, that's 43.28. What's the latitude of Madison? 43.007. Boy, that's pretty good for just going out with a tape measure under duress and coming back in with those numbers. So I wanted to show you that. Pretty cool. Fun things you can do when you are a nerd. Thanks.
Thanks, Jared. That adds another angle to our discussion, I guess. If we could go to the 850 map first, just one quick thing before we get to the some other elements. So, I always like to do how warm could we possibly get today, and you see that we're in some warm advection, but it kind of halts as you get into central Iowa where the temperature gradients kind of relax. So the maximum temperatures in this region are probably 5-6 degrees or so. And so that air is upstream of us. It'll be over us later on this afternoon. With any sun that we get outside and the mixing, you add add about 9 to that. That gets you to 14. So we could probably get into the middle to upper 50s with sufficient sun and mixing. So 58 probably as a max for later on this afternoon. So that 850 rule is often a good one to use as you're trying to figure out what's the maximum temperature going to be. It's relatively dry outside. It's not super dry, but sunny, windy, getting on the mixing. That's probably where we're going to get for today. So the first thing I want to do is, for the last month, I've been saving images for this very day. And this goes all the way back to the 21st of February. I've been saving forecast images. Let's go to the end of this first, just to see. Yep. So this is taken from 0Z last night, short-term 12-hour forecast, initialized last night from the CFS. I just kept the model consistent. And as we saw just off the East Coast this morning, that departing cyclone, we saw the 500 millibar trough here in thickness. We can see where it's located. We can see that weather system in central Ontario with a cold front or the beginnings of a cold front extending to the south of it. And let's just take a very quick step backward in the images. So we're going to go from 0Z analysis from last night to 12Z yesterday, and just keep going back. And you can see we've kind of locked into a forecast for the last several runs with a trough just off the East Coast, maybe a cyclone center of precipitation ending in New England, the weather system up in Ontario. This is initialized on Monday. Again, very similar sort of pattern, but as we go further back, it's around this time I think that we begin to lose any sort of coherence in the forecast. Things begin to really look different. Is this the same weather system? It's not clear. Maybe we're bouncing back to that, going back to Friday of last week. And then things really begin to just sort of get lost in terms of where's this cyclone actually going to be. So these are all forecasts going as far back as almost a month or halfway through, valid at the same time, and you can sort of see where the certainly the loss of predictability exists. But it's really interesting that we kind of locked into things in the last 4 or 5 days. So here we're at 672 hours. So I first showed you this back on Weather Watch on Friday, the 21st. I didn't show you this map because it wasn't out yet, but something very close to it from the late February. We're looking at that. Is this the same cycle? This the same cyclone? I wouldn't say so. I mean, you can use your imagination to say that's it, and here's that little wave that ultimately became our cyclone in the analysis this morning. But that's a stretch. But again, if we just go forward one more to get to the, go back, forward, backwards, actually, I don't know. Here's the, again, if you just look at the last couple clicks, this looks very, very similar in terms of the forecast. So locked in, and then just the broad pattern, again, getting specifics right several days out is going to be tricky. But we have this sense of a trough along the East Coast, and a fairly thin cycle. Even this forecast from last Friday kind of suggests something very similar. Doesn't capture the cyclone in central Canada, and I mean, I'm not expecting that it would. It's just kind of an interesting development, not development, but interesting aspect of the forecast and looking at where things kind of lock in. So that's it.
Michael, I was just gonna say, on March 9th,
Yeah.
there was a big sudden stratosphere forming event, which are known to be sort of the predictability leading up to that is not very good, but the predictability after that is when you sort of like have a forecast of opportunity for extended timescales. So it would be interesting
Great.
to do this again, knowing that
We're now in a regime that's more
yeah,
predictable.
right. So
How fast do you see the signal emerge for increased predictability after the warm?
It's usually once the event is resolved in a forecast, which this one was very sort of not well resolved, except for in the few days leading up to it.
Okay. And how long does that window of opportunity for good forecast last?
About a month.
Okay.
Or increased, shifts in the PDF of an event happening, a cold event or,
Okay, that's
So-
really interesting.
Might an expectation be then that if you're in one of those periods, you'd see that coherence last a little longer into the
Right,
past?
yeah.
That's really interesting. That's
Yeah.
very cool.
Something to, certainly for any folks out there that are interested in looking at that, to grab the data and begin looking at it.
There must be a whole landscape of mathematics that, of which, of course, I don't know anything about, but how does one compare a regional analysis for accuracy and especially in a time series where you kind of know you've got weirdo initial conditions at 380,000 hours ahead like you like to look at. And then you have better ones when you get in close. I mean, you have much more coherence. You can see that by eye, but I wonder if there's a way to measure that coherence over whatever specified region you decide. And it's not probably just a anomaly correlation coefficient. It's got to be something a little
Yeah.
more than that, but I don't know what it might be.
Yeah, that's an interesting question, how to
yeah, there's like
best measure this.
looking at the leading patterns of variability in the forecast, so like looking at the EOFs of the
Yeah,
forecast
okay.
to see you know, which thing is it capturing the best? Is it the cyclone off the East Coast? Or is it the ridge
Yeah.
over, you know, Colorado?
Right, so if you're looking at the variability from forecast to forecast.
Right.
Yeah.
Right, so if you looked at that, and that'd be also interesting to look at that over the course of a month for a given, you know,
Yeah.
in terms of verification at some chosen time, and then to look to see which component of that variability begins to emerge in terms of what's
Yeah,
gonna be
that's true, yeah.
the most
Yeah.
accurate,
Yeah.
the one that projects strongly onto the final time.
Yeah, exactly. Yeah,
forecast.
because you'd like to be able to follow individual elements or regions within a broader region for that reason, yeah. Something coherent might come out of feature A before anything else,
Yeah.
before the whole ensemble of features comes out coherently, yeah.
Yeah, so.
That's interesting.
So that's the last of this, you're not gonna see any, I'll still look at long-range forecasts and throw them up here, but you know, we're at today, and so.
But you won't try to give them credibility anymore.
No, I won't. Never had. So let's go now to Tropical Tidbits, her 12Z run, and we'll just look at the passage of this upcoming cold front that's, as Patrick noted, we have this weather system in Ontario and a tentative cold front that's heading southward. And let's go to the mesoscale model, we'll go to her, and then we'll go to 12Z run, please. And we don't have to zoom in. Let's just step forward quickly. Let's step forward about 12 hours from 12Z. So what we're going to see in the forecast is that the passage of this cold front, as it gets in here, will be, could possibly be associated with a bit of precipitation as this weather system begins to arrive. Frontogenesis on the leading edge of the cold front due to differential temperature reduction, and you can even see, if you imagine my fingers being isotropes or isotherms, you can see very clearly the difluence that's associated with that disturbance. I'm going to keep this because we're going to do some cross sections in a second, but the other, let's bring up pivotal again, and let's zoom in. Let's go not North America but regional, West. And let's take a look at the next set of the surface. Let's look at temperature and wind marks. And we'll go ahead to 12 hours. And so you can see by this time period, you can see the gradient temperature here. It's not the greatest signature here in terms of the actual wind, but there is a bit of difluence here, and so there's frontogenesis along this band, and this is what's going to be coming through just around 0Z, so 7 p.m. this evening. We're going to see the wind shifting from that southwesterly direction. Again, the transport will be, we're going to really warm up nicely this afternoon before the arrival of the front, and then with sunset and cold advection beginning to set up, it's going to cool off. And so one of the questions is, will we see any precip? And I think that's going to be, the air is fairly dry. That band of precip that showed up in the HER, I'm not sure if it shows up in subsequent forecasts. We'll go back to it, please. But that's the first weather system that goes by. So let's go ahead very quickly to tomorrow morning, 7 a.m. This weather system has now gone by us. I like this to a certain extent, but I wish we had isotherm on it, but that's all right. We're in, tomorrow will be notably colder than it was today. I don't think we can do it, just do a sounding. We click on this. There we go. So this nearby sounding, again, you see it's going to be, by tomorrow morning, 29 Fahrenheit, and it's going to take a lot of insulation and mixing. It'll be somewhat breezy for us to really warm up significantly. We have this fairly significant inversion over us that we're going to have to sort of break through to be able to warm up. But I don't think we're going to get, the warmest, if we could break all the way through, that would be back up to 50, but that might be a challenge. In fact, let's just see how well this will work. If we go to, just go ahead to 30 hours by mid-afternoon, or early afternoon tomorrow, we'll submit that. Yeah, it's going to be tough. And you can see that there's, again, the strong winds aloft, and that stable layer just above us, it's going to be hard for significant mixing to reach the surface. Then we'll go ahead another 3 hours to late afternoon. Yeah, so tomorrow's not gonna be the most pleasant of days. I mean, again, you can see significant dew point depression, so it's very likely we're not gonna have much in the way of, certainly low and middle-level clouds over us tomorrow. All right, so let's get out of this and move ahead. I'm gonna kind of mix it up because I like to do prefer the presentation here and scroll down to just the more traditional surface map with thickness on it. We're gonna come back to tropical tidbits and do some cross sections in a moment. So this is 12Z, cumulative precipitation. Let's go ahead to tomorrow morning, or to afternoon tomorrow, 33 hours. Okay, so pretty quiet day tomorrow. Nice anticyclone over us, big bubble, no trouble, so weather should be pretty neat. And we go ahead to Sunday morning. And warm convection begins to start in earnest, and we can back out to the full U.S. map at this point. And fairly nice cyclone over central Minnesota, strong warm convection to the south, and you can see sort of, this takes a while for air that's maybe had its origins out the Pacific or maybe even the western Gulf of Mexico, has to lift pretty good distance before it actually becomes saturated and then begins producing precipitation. And so one of the things I'd like to do, and we'll do this in tropical tidbits, I think this is about, let's go ahead, before we go to tropical tidbits, go to 54 hours. I'm gonna go through the warm sector, and we're gonna construct a cross-section from northeast Louisiana up to the sort of tip of Michigan. But we're actually gonna do it at 48 hours. I think that's the time we want it. But we'll go from this location right here to just northern
You're on track.
Michigan. Untropical, but we'll do it at 48 hours. So let's select the time here. We're cutting kind of through this developing,
That's where you wanted to start.
so right here, up to here. And then just submit that. So this is going to show frontogenesis. What? I looked at this.
Is there no temperature?
Go to 48, go to 48.
Oh.
What's going on here? That's 48.
Did you want GFS or?
This is
Yeah, this is not
36
even time,
hours.
right? This is 36. Why is this not? Because I looked at this. This was a really nice cross section. So I was dreaming this. Is it not done yet? Could I possibly be looking at something a little different? All right.
Is it the
Well,
wrong run, maybe?
let's just go to
12Z. Oh, yeah.
Actually, let's go back to models here. Was it 3 kilometer? Yeah, that could have been it. Let's go to, yeah, 48 hours. That should come up. And let's try this. Yeah, all right.
That's nice.
So, yeah, so this is showing us, we have theta E here in the gray contours. The shaded pattern is, well, this is vertical motion, ascent, which is the significant ascent. Here's our frontogenesis along this developing warm front. And, I mean, the fact that this is more upright, that's partly frontogenical, but it's also perhaps with weak stability. This is probably convective as well in nature. Right along, in this area that's just in southern Illinois and southern Indiana. Well, that was a nice cross-section
Yeah, it is.
for this, to see where that, how that precipitation is setting up. If we do another cross-section, we're gonna do it normal to the cold front. So this is air that's moving toward us. There's precipitation. This is on Sunday morning, so Sunday's gonna start off with some clouds, and then rapidly, things are gonna go downhill in terms of the arrival of precipitation. Let's go forward a couple of, to early afternoon, as the precip comes in. And, one of the questions is gonna be, will it be cold enough for this to be frozen precip? We go back to mid-afternoon. This is coming through or late morning, I guess.
Couple one.
Go back a couple more, please.
One more. Because then it looks like it's almost snow.
Yeah,
Just to our.
so let's do a sounding.
35-degree rating.
Yeah, that's probably right. 35 degrees and rain. Right?
35 and rain. This is everyone's favorite weather. Welcome to spring break, right?
Yeah.
So, yeah.
It's gonna be this
So,
cold.
I mean, most of the column is below freezing, so
This
that's
is
that
this is
last
where the
little bit.
raindrops have ice on your windshield.
Yeah, right.
Yeah.
It just freshly melted or something.
Really sloppy.
So, and if we start
Maybe we'll get
keeping this location and just going forward, it's gonna be a, competition between when the precipitation, we can just do a quick.
Oh, yeah, it's a little bit of cooling there.
Yeah, just a bit of cooling, but then the precip's over, and that cooling is probably accentuated by just an increase in upward the vertical motion, cooling the column a little bit. And so this is into
Never
Sunday
goes to
afternoon.
snow for us.
So, maybe wet snow and mostly rain coming through early Sunday afternoon.
But it rained.
And then we get, we'll get out of this,
I guess if the 3 inches of snow still must have passed forward to us.
and we can step forward and look at the progress of this.
Right.
Again, now we're getting a nice cold front setting up to the south. We can do a cross-section through this. It would go from hopefully there. So we don't have to go all the way down by hand. Oh, we can stop in South Carolina, let's say. So it's nearly the center part of this.
Yeah, that's good.
Okay. And Genesis doesn't show up well, but the vertical motion, you can see the ascent here. And again, this is theta E, not theta that's shown, but you can sort of see the leading edge of that front. And sort of a, not well mixed, but it's a boundary layer that's weakly stratified where we're getting some of those deeper bits of convection. And the front of Genesis is well to the northwest of this. It's actually back in here, not really at the leading edge of the front. It may not be the best cross section that I picked, but that's what we have. Let's look at a couple of other PV in this. So that,
Yeah.
so you can see here in actual theta, temperature, the surface runs way down here, and very elevated tropopause, and a thin strip of PV. I don't think that's necessarily, that could be an upper front. I don't know, John.
It's hard, I don't know what the rest of the context is, doesn't
Right.
look like it though. To
Right.
me, it's too far removed from the jet core
Right.
to really have had that origin.
But we'll get out of this and go back to just our, we'll go back to pivotal and just go ahead in some big broader chunks, 72 hours to this is out of the way.
Cold.
And, the pattern that we see here is one that's gonna kind of just sort of repeat itself over and over during the week of spring break. Forecast that we have for the next 6 to 10 days or so from NOAA, you can go up to that to forecast, are for below normal temperatures during this period in terms of CPC outlook. And if you want to enjoy nice weather during spring break, go south and go west.
Cactus.
That's going to be pretty nice weather. And then the 8 to 14 once we're back, again, welcome to spring in Madison. It's going to be sort of likely below normal. Doesn't mean that we won't be a few periods where we get above normal, but it's not looking like it's going to be a particularly warm spring break. And in terms of precipitation, if you look at the precip, it's above normal, likely above normal for both time periods. So that's what we're going to do. Anyway, that's all I really have to show or describe. Frontal passage is after this evening around 7 p.m. or so. We'll see the wind shifting, getting up into the mid-50s, full sun. And then tomorrow, a colder day, low to mid-40s at best. And then tomorrow night, clouds increasing, period of rain, maybe mixed with a few flakes of snow on Sunday, early afternoon. That gets out, and we just say it's kind of cloudy and miserable for the rest of Sunday.
Well, that's a nice
That's it.
one.
Great weekend for a break. So anyway, have a wonderful spring break. Have a safe one. Thank you, Patrick. That was a really great recap of last week's weather. And thanks, Pete, for helping with the images and running the whole show.
Thanks, Pete.
Have a
Thanks,
great break.
Thanks.
Thanks.